It does not appear to be a typical comet where a stunning dust tail can be seen stretching away from the direction of the sun. The information came from millions of miles away from the ExoMars orbiter. On a set of screens at the European Space Agency, a fuzzy blob sharpened into a chillingly clear picture. There were 3 atlases here, an interstellar traveler hurtling through our solar system. However, as scientists stared, a sense of confusion began to grow. The majestic tail did not exist. Its glow was facing the wrong direction. It was moving in a way that almost seemed deliberate. This single image, meant to provide answers, instead revealed a terrifying new chapter in our search for what's really out there. Through a telescope, the first meeting. The muteness of space has no boundaries, but on Earth, the noise is unbearable. Just hours ago, the ESA European Space Agency did something that has the entire world buzzing. They released the first ever detailed image of 3 Atlas, a mysterious object that has journeyed for millions of years from a distant, unknown star system to arrive in our own cosmic backyard. And to put it mildly, we were not told what to think about this object. Until now. We've only been able to see hazy pictures taken by telescopes like Hubble, faint, glowing blurs. But the new image captured by ExoMars' advanced CAS camera aboard the Trace Gas orbiter is on another level. The orbiter, on the other hand, was not built for this. Its primary mission is to sniff faint gases in the Martian atmosphere, searching for signs of life. But engineers pointed it toward the void in hopes of seeing this explorer from another galaxy. What they captured has thrown everything into question. The picture depicts a bright, centered core, but the exquisite sweeping tail we expect from a comet just isn't there. That detail was omitted from the initial excitement. Normally, when the sun is up, comets form tails as their ice melts under heat, pushing a trail of gas and dust away from the sun. However, 3 Atlas appears to be following a different set of rules. The dim light it does have seems to extend toward the sun, not away from it. It's almost like seeing the wake of a boat appear in front of it instead of behind it. It just doesn't make sense. Harvard professor Avi Loeb, one of the most respected and outspoken astronomers on the planet, pointed out that the new image from ExoMars supports what he said earlier based on Hubble data. This object is weird. There's the bright, clear core, but its surrounding envelope of gas and dust is faint, almost non-existent. The orbiter's camera is much smaller than Hubble's enormous 7-foot mirror, meaning it can't detect faint, widespread glows very well. But the sharpness with which it captured this clearly defined core without a massive tail tells us something crucial. This object does not shed material like a normal comet. So, what is it? Many people suggest it's simply an unusual space rock, but the list of anomalies keeps growing. It's huge, far larger than Oumuamua, our first known interstellar visitor. Its trajectory is yet another mystery. The object travels along the ecliptic plane, the same flat disk in which our entire solar system's planets revolve. The odds of an object from another star system being in such perfect alignment with our planetary plane are astronomically low. While not impossible, it's definitely suspicious. This thing behaves less like a wandering stranger and more like something on a guided tour. But that strange trajectory is only the beginning of this cosmic mystery, one that defies the laws of physics. Most people don't realize the vast majority of space is empty. Objects traveling between stars should follow erratic, chaotic routes coming in from high, low, and every possible direction. That's what made Oumuamua so normal in its abnormality. It sliced through our solar system at a steep, random angle, but not 3 Atlas. As mentioned, it entered our system on the ecliptic, and its course appears almost engineered for close encounters. This is evident throughout its trace data. The object made a surprisingly close approach to Mars, just 30 million miles from the red planet, before continuing on a course that brought it near Jupiter. These aren't just flybys, they're significant gravitational encounters. For a natural object, this path would be a series of incredible coincidences. But for something with a goal, it's the most efficient way to use planetary gravity to adjust its course and speed, a maneuver NASA often refers to as a gravity assist. Are we being used by 3 Atlas? Are our planets helping it explore? Let's talk about its size. Although exact measurements are difficult from this distance, early estimates suggest that 3 Atlas is massive, possibly several miles wide. For comparison, the asteroid that wiped out the dinosaurs about 66 million years ago was only a few miles across. We're talking about an object with enough mass to be a significant celestial body. While large comets do appear in our solar system, finding one this big that has traveled across the vast emptiness between stars is highly unusual. The journey through interstellar space is harsh cosmic radiation, and endless time should have eroded a much smaller object to dust. The enormous size of 3 Atlas implies that it is either extremely durable, or it hasn't traveled nearly as far as we think. And then there's the greatest mystery of all, the missing tail. The new ESA image confirms it. When a comet nears the Sun, it should rapidly outgas, creating a glowing coma and a long, dramatic tail of ions and dust, the very hallmark of a comet. But 3 Atlas barely has one. It shows a faint coma, a tiny, oddly shaped haze, but where is the debris? An object this large should be shedding tons of material every second as it warms up.